being recorded, right?
Yes, yes.
The first question is like palindromic substring. We are given a string and our task is to count how many palindromic substring is present in this string. The substring with different start indices or end index are counted as different, even they consist of same character. So like here ABC is there. So single character is a palindrome in itself, and here all these six. And regarding the note is the input string won't exceed the length of 1000. Yeah. So what would be the brute force here? Like,
Okay. So if we had lower and upper cases of same letter, so will they be considered as different or same? I think, yeah, that should be different, right? They have not
yeah,
mentioned, yeah,
yeah,
because the ASCII values are different.
different, yeah, exactly.
Right, yeah. I think other than that, there is nothing much to get,
Constraint.
yeah, the requirements to be clarified.
Any special characters can come.
Yeah, even if they come, they should be fine, right?
Yeah, yeah.
They should not be a problem. We can consider them as a separate one. Unless we are specifically using it for some reasons, in our algorithm. Yeah. So the brute force would be like, start with a single length of 1
Okay.
and then keep on incrementing the length. So when you go for length 1, you again go and have a substring of starting from the 0th index to that length for each and every from each and every index of the string, right? Yeah, and then find if it's a palindrome, and then keep on incrementing our answer. Yeah.
So generating all the substrings and then checking.
Right. Generating all substrings of each and every length from 1 to n-1, and then check if it's a palindrome for each and every substring. Yeah, makes sense. Yeah.
That makes sense. So, so what would be time complexity there? Like for generating the substring, it should be O of n square, right?
Generating of substring will be O of n, I think, right? And then checking will be another O of n. Or no?
Generating substrings will take n square, right?
Yeah, n square it should be. Every time we are doing from beginning and increasing, right? I mean, until unless we are using two-pointer approach.
No. I'm just okay. Yeah, the real brute force. That is what last someone said, right? Yeah. Okay.
Yeah.
Yeah, should not be the 2-pointer. That will be an optimized version, right? Yeah. Yeah. So it will be n cube total.
Yeah, it will be n cube.
Okay. So,
Hi.
Yeah, go ahead.
So just to understand this correctly, for your solution is that you will go to every index in the string, and then you'll span to left and right to figure out if it's a palindrome or not. Is this correct?
Yeah, this is good. That will be a sort of a O(n) square solution, right?
No, O of n. Maneker's algorithm is talking, I think.
No.
Maneker's is a little, I think, would be a little advanced, but I'm just one step down version of Maneker's, which is, you go to every index and then you span, to the left and right to see whether, the indices are matching. As long as they're matching, you're finding a palindrome.
Right.
And then, so it would be n square. I'm not sure how this n cube, if that would be n cube or how this is n cube.
No, that should be n square, I think, right? Because you are going to each and every index, and then you are expanding from that index from the center to the left and right, correct?
Right.
Yeah. So that should be n square.
Yeah. So for every n, you are moving n. Yes. Kind of. Okay.
And I think that gets accepted as per this solution. I think this is fine. That is fine.
number of centers will be n only, no?
Number of centers will be 0 to
And
8. Correct. Yeah.
it can be n+1 because you can have an even length string. Like if let's say a b b a,
Okay.
then if you see every index, you will not find a palindrome, but middle of the index, right? A b b is still a palindrome. You see what I mean?
Right. So it will be an odd length and even length palindrome.
Yeah.
Yeah.
So it will still be in order of n, but the total indices I think would be 2n plus 1.
That might be something. But then it will still be n square, correct?
Yeah, still be n square, I believe.
Yeah.
I haven't checked though yet.
No, I think that should be correct. Yeah. Unless if someone has something to say on it.
Yes. Do you have implementation for the one you are saying?
And
You're talking to
Biju, for you.
No, not right now.
Okay.
I have the implementation for the same approach.
Okay, sure. You can go ahead. And the good thing about the space complexity in that is it will be
Constant.
One. Constant. Yeah. Dilip, go ahead.
So these are when we're talking about one center and two center, right? Like taking one character as a center of the palindrome or two characters as center of the palindrome. So those are these two loops. So each one, like almost they both have the same code. Each starting with the left and right. It's a one center, so both left and right starts with the same index. Index is from 0 to length of the string, and I will expand them both on both the directions, like -1 and +1, and keep counting if they are both same. Otherwise, I break it in. So that's how I get one center.
One center is odd, right? For odd length, you are checking one center.
Odd length. This is odd length. And this is the even length string where I take idx -1 and idx are the centers. So it's the same code actually, like expanding both the directions, and if they are equal, I increment or else I'll break and return the counter there.
Okay.
You could have combined these two methods as one method also.
Yeah, I just want to make one condition for 0 or something, and then I can continue this, but I just want to write it just two loops to make it clear. But okay, maybe that's better actually. It's just one condition.
So here 2 passes will no. So it's like O of n square only, right?
Yeah. This is always good.
Yeah. Absolutely. Yeah. So mine is just similar to what Dilip has shared just now. So you'll have these many centers in your string, and this is for the odd one, and this is for the even. And same thing, like as long as your left is greater than 0 and right is less than n, and if both are equal, then in that case you got one palindrome. So increase result by 1 and go left. I mean decrement your left by 1 and right by 1, and again same thing, it will keep on continuing till the right. I just clubbed both of them in the same.
Right. Yeah, that would be an efficient way of implementing it also. Yeah, that is good.
So it is also n square only.
Yeah.
So at line number 7, what is this double division sign in Python? What does this mean?
Double division is like it will give you quotient. Integer value you will get.
Okay. So Python does not have single division sign.
Yeah, mod we take for that. No, single division sign is not there. Like 7 by 2, it will give you 3.
Single division will give you, I think, decimals.
Yeah, decimal it will give. That
It
is.
will give you decimals. So 7 by 2 would give you 3.5. By this would give you the integral value.
Yeah.
That's good. Okay. So we could do it using a DP also, right?
Yeah. That is what I was about to ask. Like,
Yeah. But in that case also still the time complexity will be O of n square, but we'll have an additional space complexity, correct?
yeah, that is a drawback of it.
Yeah.
But advantage is like if your length is if this is increasing, yeah, then that would be good using DP, right? But here also it shouldn't affect much, right? Even if the length exceeds like 1 million, something like that.
Yeah, technically it's time complexity will be the big of n square, right? So it should
Yeah.
not cover. In
So
DP
maybe
also
DP
it will
would be
be.
the good one for this.
But in DP, actually, if you use the bottom-up approach, okay, so it will still be n square, right? O of n square time complexity, and it will have an additional space also.
Yeah, you will not hit TLE in that case. But here I think we can hit TLE. I'm not sure. That's why they have.
I don't think so. Why it should hit TL here? Because the
No,
time complexity of both will be same, right?
yeah,
So it
but
should not.
there we are reusing the results no in bottom up already, which we have computed the result.
But still, it's O of n square.
Yeah, your time complexity is of n square only. Okay, yeah.
Mm-hmm. So
So do you have something?
how do we do in a DP? It will be like yeah, I have the bottom up approach.
Yeah, sure.
I
So
can share it, but I'm not sure whether it is the right thing here. But okay, I can quickly share that.
I think diagonal will always be true. Like single elements is always a palindrome.
Uh,
Yeah,
yeah,
right.
Hmm.
That would be the
right.
base case.
This is yeah.
Yeah, actually, I didn't use the top bottom, but if I use the bottoms up approach, so I'm having this DP array here, and then this n is the size of that string. I'm having a two-dimensional array of n by n, and this is my count, which will return the answer. So initialize to 0, and then initially I'm going through each and every
Diagonal.
diagonal one, right? Yeah. So I'm just making that as true, and then I'm incrementing the count here. Then I'm taking count of the neighbor ones, right? I and I plus 1.
So this is above diagonal, right?
Yeah, after diagonal. Yeah, but it is above the diagonal. Yeah. So when I think the length is of 2, I'm just taking both of them are true. Then I'm again incrementing them, and then again I'm starting from L equals 2 and going to n. And then I'm actually going here for each and every I and j value, right? So in this case, I'm looking for if my S and j is same, okay, and then I'm looking for the I plus 1 and j minus 1. If they are true, then I'm incrementing the count, and then at the end I return this count.
So intuitively, what it is doing 83 to 91. So it
Yeah,
is.
this loop is not clear. Like the above two loops, I understood left to right bottom diagonal, and other one is right to left diagonal.
Yeah. So if you go if you take this is sorry, I can't do it yet. Oh man.
J minus 1, one column back it is taken. Okay.
Yeah. So it will be like if I have a yeah. So I'll have to go one row down and then the previous column, right? So just
Yeah,
check
so
it for if
it's like, I mean, sorry, all the diagonal you made first as true, right? These diagonal elements.
right.
And for above the diagonal elements, we are using this loop, this one.
So yeah, that is the second, which is actually in parallel to the diagonal again.
Okay, yeah.
Yeah. So
we
that
can
will be
avoid this loop. Like we can use that in this line number 83 loop.
right. Right. Yeah. We can do that way also.
Hey,
But
sorry, Santosh, I'm not getting the intuition behind this DP solution. Could you please care to explain a little, like how this is solving? What do we have this in the two-dimensional array that are we storing?
okay. Can you, Shashank, can you open your, so I can actually write on that one,
Yeah, yeah, sure, sure.
I can
Sure,
share my code. It's the same only.
Okay.
yeah, go ahead.
Yeah.
Mhm. So can you draw that table and then like more? I mean, only few
Let me
examples,
draw
not
that.
much.
Okay, what I will take is one example, maybe S if equals maybe M, A, B, A, and Z, something like that, right? So in this case, what happened? Okay. So in this case, we'll have 1, 2, 3, 4, 5, okay, and 6, correct? Yeah, we'll have 6 as an answer, right? So now 1, 2, 3, 4, 5. So if I have an array of 5 by 5, right? So this is 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, 5. And this is my column MA, BAZ, right?
Should
So
we say
this is
6
my
by 6 or
MA,
5 by 5 is enough?
BAZ. I'm sorry?
I'm saying 6 by 6 or 5 by 5 is enough.
5 by 5 is enough. That is what I did. Okay,
Okay.
so I'll just go by that approach, right? And then first what I did is, because this is a Boolean array, right? Two-dimensional array. So then I set all, initially it is all set initialized to false values. So these are the diagonal values, right? So I set all these diagonal values to true first, right? And in my second loop, when I was checking for the uh, two length, then I just comparing, like, if in this case, if m is
So
equal to a.
what does true represent? Is it saying that all single character strings are?
So, okay, the whole array is initialized to false. Okay. So when true, it means like m equals m, right? In this case, a equals a. If you look at the column and row, so this m equals m, a equals a, therefore this is true, b equals b, because they are the single characters, right? So that is a
Okay,
palindrome. Okay.
okay.
So when I come to M and A in this column, when I'm taking two letters, okay, at a time, that is length is 2. So I compare M with A, it is not true, therefore it is false. A to B is also false, okay, and then B to A is also false, correct, and A to Z is also false in this case, correct. So now then what I do is I go for 3 number of this one, right? So when I'm doing this, okay, so what I do is I actually go and when M and B, they are also not common. So this will be false. They are not same, right? So now A and A is true in this case, So for that, I need to check if my I plus 1, that is this. So in this case, this is 0, 1, 2, 3, 4. These are my rows and these are my columns 0, 1, 2, 3, 4, right? So now I am on row equals 1 and column is equal to column equals 3, right? 1, 2, 3. Okay. So when I'm looking for this, when I find A equals A in this case, so I need to also look for I plus 1. Okay. So I plus 1 in this case will be 2 and J minus 1, which is equal to also 2. So I need to go and look for this 2. Okay. This column and then this column. If this is true, then only I mark this as true. Okay. So you got the point, right? So if this has to be a palindrome, okay, so I need to see if there is another because I have to have another letter also to be same, right? So this will be a palindrome in this case, correct? So because I have to check if I have anything true, so based on that I make this true, and then I come here, B and Z is not true, then I make this false. Okay, so in this case, what I have 1, 2, 3, 4, 5, and this will be the sixth one. And rest of these all will be false in this case. But as soon as if I make this B as A, in this case, the whole thing will change, right? So here this is false, so this will be true, right? So in this case, this will also be true, right? And this will be false. So we have two trues here. Okay, and then for the third one also, this also is going to be true, right? So in that case, I will have this 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6, 7, and 8. Correct. If I make this as A, right? So at that time, it will be 8. So whenever I just look for this T, this was important, right? So when I look for this one, I need to look for a diagonal down. If that is true, then only I mark this as a true. And then only that this becomes a palindrome, because this is the way it will be a palindrome, correct? Yeah, so this is the way the bottom
got
sub
it.
is.
Got it.
Yeah.
Thanks for explaining. Thank you.
Yeah. Yeah. Okay. So, but actually here also our case will be, more what you say. It is going to be n square, as well as space complexity will also be n square in this case, correct?
Yeah.
Yeah, okay. So what is Harshit doing? Harshit actually is doing the same for line number 8 to 10. He is doing the diagonal one, and then he is using the same value. Okay. So yeah, if the length is 2, yeah, that was an additional thing what I did, right? I should have started with length 3 in that case, correct, Harshit? Because using 2, you are able to do that, right? Oh, you are doing that explicit there, okay. Or else you are going to do it here.
So he's first checking for 1 length, 2 length, and 3 and more than that.
Yeah, so he is doing that. But do you have to do that explicitly here? You could have done it without line 16 also, right? No?
This thing?
Mm-hmm.
No, this condition would be false, no? Like if you, this would be negative.
Oh, okay.
So
So
if your
anyway, you have
I,
to do it, right? That way.
yeah, if your I something is 0 and j is 1, then I plus 1 would be 1 and j minus 1 would be 0. Right? So
yeah.
this would not hold true for length equal to 2.
Yeah, got it.
Yeah.
So either you do out of the loop or you do inside the loop, but you'll have to do
Take it,
explicitly.
yeah, handle it separately.
Yeah, got it. That is the reason people are doing as a separate out of the loop also. Yeah. No problem. Good one.
Yeah. Okay.
Yeah. So other than this, there is that Mannekes algorithm also, which goes in O of n log n times, correct?
No, Mannekes only, which I was saying, right?
Which one?
The one which I was sharing, like go to the center of the screen and expand left and right. That is only Mannekes, right? Or
No, Mannekes is not that. Mannekes will be like you are actually, your time complexity is just O of n. In your case, also that was O of n square, correct?
yeah.
So Mannekes does everything. The time complexity is an average of O of n.
Oh, so Yeah, I was also thinking, but the I mean approach is like this only, right? We find the center, and if we find left and right are similar, we expand. Is it? I'm not sure.
No, it's
There
different.
is a slight difference with Maneker. You have to pre-process the string beforehand. So I've pasted one link. Maybe that will show you rest. Some of the thing is common with that center thing, which you were saying.
Okay.
Okay, but so in that case, okay, do you want to go through that?
It's very difficult. I've seen this lot of times, but I always forget.
Okay. So what they do, actually in this implementation, in our solution of a LeetCode, okay, so what they are doing is actually they take the length of the current string, okay, and then they add the hashes, right? So between each and every letter. Okay, so to take care of the odd and even length of a palindrome, right? So then that is the reason. Okay, I think this is also the similar approach, right? You have t of length. Okay, and then you say mirror, which is that is the center. Okay. Okay, this is slightly different though. But then I've seen that they are adding hashes in between all the letters.
You can go down a bit. So they have added hashes. In this page only, you can go a bit down. No, the Princeton page.
Oh, previous.
Okay. So then what happens, like every time we have a center and then we have right and left, correct? Because if we have a palindrome, we'll always have a center of that palindrome and we'll have a right and left indexes, which will form a complete palindrome. So, but they are saying that you can, ignore the left, because if we have center and right, we should be able to find the left also, correct? So
Yeah.
based on one single pass, and if you are going through each and every index, and if we pre-process the string like the way they did for adding hashes for between each and every letter, and then when we come across, if both of the neighboring letters or whatever, like when we actually go from expand from the center and we go to the right, means we also go to the left in that case, and we find both of the letters to be same, then we increment, because we are using another array to store the number of matches, right? So that integer matches we can store, we can keep on incrementing based on wherever the index we are when we are passing in a single pass, and then we keep incrementing. So whenever we find your index actually is index, and as well as the incremented value of that particular index increases more than your right bound, then you change your center again. And also when you change the center, you also move your right, because now you have expanded your palindrome, or maybe you have encountered another new palindrome which is to the right side of the current palindrome, and then you keep on incrementing those values, right? So okay, I'm just okay.
Yeah, it's somewhat like that. It's
Yeah,
only.
yeah, yeah. So
So how
here,
is it taking care of odd and even by introducing that hashes, right?
yeah, when you include the hashes, because when you include the hashes, you are actually going through that whole string, which is almost 2 into n plus 1 size, right?
Yeah.
So therefore, you actually encounter take care of the odd and even lengths both.
No.
Yeah. But there are only two small things we need to take care of. Rest of the things are okay. Because I was slightly comfortable with the one what we have in that the solution. I'm not saying I also completely understand that, but to some extent, it is slightly easier. Yeah, I didn't read all this one though, but this also might be okay.
So there's a good example that Geeks for Geeks has actually given for Manacus. I mean, I did not. This is my first meeting, so I was not very sure, what to expect. But yeah,
Share the link. Okay.
I can share the link. Yeah, and then it's like they have clearly explained this whole, this whole algorithm, which is good.
Okay. Yeah, you can share the link.
Sure.
So in this case also, if you look at in the pre-process when they are doing it, so actually you look, if the length is here, it is twice the length plus 3. Okay, so the reason why they are doing 3 is, if you see t of 0, they are setting it to $. They're adding these 2. The whole string actually, which will be 2 into s dot length plus 1, and then they are adding $$ to the start of the string and
At the rate.
at the rate to the end of the string, right? So they are adding these two things, and that is the way they are constructing. So almost the same what they have done in this solution also. Okay, so now this is the pre-process, and how is the main, where is the main algorithm? So this is the longest palindromic substring. Okay.
No, this is like initially length is 0, and they are taking centers till the mid of the no, till the entire length. Every element they are taking, every index they are taking as a center, right?
Yeah, every index has to be center, and then you have to expand and look for whether you have.
But it's again.
This is slightly different,
They are
but
giving
yeah,
one.
they are. Yeah, actually, when you see the substring, what they are converting. So this is okay. This is something different. Yeah. So they are actually center minus 1 plus length divided by 2, and center minus 1 plus length divided by 2. Actually, it's the right and left indexes of the s dot substring, and then it is returning from this palindromic substring. Okay. Okay, I think this is slightly different because this is the even and odd. What I think, right?
Yeah.
Okay, and then how? Okay, but I think this is the one what you almost explained, right? This is
Yeah, it was similar to that.
the one what
But
you
I don't.
explained, but
I think only I'm not doing the pre-processing what they are doing here, like appending the hashes and inserting hashes and appending and prepending that.
but yeah, but that is not the really the way what they have discussed in the solution. So that is slightly different.
Different, yeah.
Can you just quickly open the solution? You look at that.
Oh, solution, this one.
Yeah, the solution one. If you go down in the solution, yeah.
This is expand around center.
No, no, you go down.
Yeah.
Yeah,
Yes.
the manicure X. Yeah.
Shall I go to code?
Yeah, just go to the code. See here, actually they did the same of the pre-processing, and then if you go down, yeah. So this is where the from line 15. So you see on line 14 you have a center and right. Okay, and from line 15 it is I equals 1 to z dot length. Z is the array of where actually you are counting the number of palindromes, and if you slightly scroll down, so yeah, so if you see on line 16, before going to line 16, if you look at the while loop on line 18, so what it does is just compares the left and right around the I, okay, and then if they both are same, okay, it slightly expands, and then it keeps on incrementing the palindromics values on line 19. So whenever you go to line 20, when it expands more than your right side, then you changes the center and also the right. Okay.
So
and
they are not doing anything with left.
because
Center is.
yeah, because if you see on line 16, when your I is less than right, so it is just taking the minimum of right minus 1, and when you see in the Z, which is 2 into center minus I, that is actually the left side, right? Or maybe this is the left and that is the right. So it just tries to find whichever is the minimum of them, and then it stores in that count. And then if you go down, then he keeps on adding. So it is almost like a single pass that they say. Yeah, even if you look at the while, there is a while loop inside it, but still it is just expanding or adding for those values which have not been incremented. That is what the algorithm talks about.
Yeah.
Yeah. So if you slightly go down at the end, then he's actually adding for all those Z values. Yeah. And that is what he says, like he keeps on adding, and that is what your answer is.
This
So
one,
that will
yes.
be of O of n as per the time complexity, what is saying. So
Yeah, open.
this one is slightly different than what I think Himanshu shared that, right?
Yeah.
Yeah. This one is different.
Yeah, it's slightly different. Yeah. I think Geeks of Geek also have explained a similar algorithms in the way they are saying. Yeah.
3 algorithms we had here.
Yeah.
It's very difficult to code this one in 20 minutes. I think.
Yeah.
Yeah, that's true. But I think the Tushar Roy's videos are also there on it, and he has also explained it why they are using. Yeah. Okay. I think let's
Yeah.
move on.
Let's go to next then. So next is global and local inversions we have to find. So some commutation of this. Go ahead.
For the previous problem, we can also think of a hashing based solution. I was thinking maybe we start calculating that Rabin cap based hash from the first position left and when once from the right, and do till the mid of the string, and if the hash is equal, then we have a palindrome. um, I was thinking of this approach also, but I'm not sure how easy would that be to code.
From
So
left
that-
and right side. Okay,
Yeah,
go
go
ahead.
Sorry.
I was saying from left and right, from both the sides you are doing the hashing and comparing whenever the hash becomes equal.
No, not that way. For each substring of length n, for n by 2 length from the left one, and for n by 2 length from the right one, you calculate the hash, and if they are equal, then
Okay.
it's a palindrome.
Okay. So you're saying that for each and every length you will have to do that, right?
Right, and then maybe we can think of some optimization to reuse those values.
Yeah, for actually one length of one, you can just ignore, you don't have to do, right? So length of
Right.
2 maybe, yeah, and then from length of 3, yeah, it is possible because the way he did it, right? The suffix and prefix you'll have to do differently. Yeah.
Right.
So you'll have to maintain 2 arrays and do those things.
So whenever suffix and prefix are equal, that means that's a palindrome.
Mm-hmm.
Yeah.
And that you're saying that should be centered at each character, or for every n it will be centered, and you are calculating hashes on the left and to the right.
No, he's taking a substring of a length. Like if we start from length 3 or 2, length n minus 1, then using that substring, he is going to calculate the hash of a prefix of the left and the right side. Yeah, that's correct. So you just divide the string into 2 parts, and then you take the hash of both. And then he says that if you are rebuilding on the top of that string, we can use the previous computed ones for the left and right for each and every previous length, and then use for the next length. Yeah, that might be possible. I never thought of it.
Bit tedious to implement, I think it will.
But then when you're moving center, right? So let's say you start with half and half of the string, and then let's say you don't find a palindrome, then you move center in either direction, and then try this approach again by recalculating the hashes. Is that right?
Won't it take much time, I think, then?
Yeah. So he's trying to recalculate, but he's saying that if we store the information and then reuse it, then at least the computation will be to some extent.
Yes.
Yeah.
Kind of DP.
Yeah, maybe, but yeah, we'll have to try it, I would say.
Yeah.
But it's good to try, at least even if it is not efficient way, we'll at least understand how things are going there, right?
Yeah.
So actually, there is no n log n complexity solution for this particular problem. I mean, from O(n) square, we straight away jump to O(n).
Yeah, because it's a palindrome, right? So you always have to look for each and every substring.
You can't change the order.
Right.
That's why n log n, I think, any sorting you can't use it.
there's no n log n solution, right? So the Maneker's comes tends to be O of n, that is what it says. But if you look at the while loop, it still uses some
n into k, something
right,
like
yeah.
that.
But he has an explanation in that saying, okay, it's still not a, it's still a O of n because it's computing the same values which you already see and all that. Yeah, something, but yeah, this should be okay. Yeah.
Yeah, sure.
Let's move on.
So next is like global and local inversion. So we have some permutation of A, where n is the length of A. And global inversion is like I should be less than j, and A of I should be greater than aj. And number of local inversions is the number of I greater than 0, less than n, and adjacent element like A of I should be greater than A of I. So we know if global inversion is equal to number of local. So if we see here, for global, the 0th index element should be greater than the any jth element. So 1 and 0 are global inversion, right? And regarding local, if we see local.
Okay, so what is local and global? So local is the two consecutive ones.
Immediate ones, yeah.
Yeah. So
Yeah.
if the previous one is greater than the next one, okay. So if it's like I is greater than I plus 1, then that is local inversion. But if you have something which is
Any j, yeah.
I is greater than I plus 2, or I plus 3, I plus 4, so then that is a global inversion.
Rule is same, only for local it's immediate. For global it can be any j. A of I should be greater than that.
Yeah, in this example 1, the global inversion and local inversion are one and the same.
Yeah,
I think every local inversion would also be counted as a global inversion.
Correct.
Yeah, correct.
So that is what actually, that is the reason it is true in example 1, because we have only one inversion here, and that is a local inversion. So when we have a local inversion, just a local inversion, so global inversion, local inversion will always be equal, and therefore it is true. Yeah.
So how many global inversions are here?
1 and 0. 0.
The first one, 1 0 1 0.
This one not
1
global.
0 is a excuse me, 1 0 is a local inversion as well as a global inversion.
Yes.
Yeah.
And 0 2 is not an inversion because it's in ascending order, right?
Correct.
Yeah.
It's an ascending order.
Okay.
So in example 2, when we see it is 1 2, so there is, we have only, we have two global inversions, 1 0 and 2 0, correct? And then we have only one local inversion, which is 2 0.
2 0, yeah.
And that is the reason it is false, because they are not equal.
Equal. Yeah.
And then A will be permutations of 0 to
length of the string.
Length minus 1. Yeah. So the numbers what we are going to have here, they will be from 0 to length of the string minus 1. So those are the only numbers which we will be getting in this as an input.
Yeah.
Right. So we are not going to get any other numbers. So that is the only reason. It is slightly. It is okay, right? So because now what happens, because as Arshit said, if we have a local inversion, so we'll have a global inversion also for that. So then what we need to look is when the condition becomes false. And the condition can become false only when we have a global inversion, a real global inversion.
Yeah,
Right?
if you check there is global inversion only, then it's false. No.
Yeah.
Yeah.
Right, Arshit?
Right.
Okay.
So if we encounter say A of I plus 2 greater than A of I, then that would be, we have to return false. Right.
A of I is greater than A of I plus 2.
Right.
Okay.
Or I mean anything greater than or equal to 2.
Yeah. And we also have the numbers from 0 to n minus 1. N is the length of A. So we just have to look out for few values, right?
Yeah.
Okay. So now what will be brute force? Just go through each and every string, each and every index. Like if I start with the first index, I look for all the numbers. If any of them is greater than, if I start with in index 0 in the upper for loop, in the next for loop I will start with if I equals 0, then I will say j equals I plus 1, correct?
2n, yeah.
I plus 2, I would say I plus 2. So then I look for if a of I is greater than a of j at any point of time, then I return false.
Yeah.
So that will be a brute force, correct?
So you're just checking global ones, right?
Yeah, I'm just checking global because that is what it comes to. So whenever we have a local inversion, so global inversion will be there. So they will always equate each other and we don't have to count them, correct?
Yeah.
So if you don't find a global inversion, the real global inversion, it means that we have to return true. So for that, if I start with the upper loop as for I equals 0 to n minus 1 or n minus 2, and then I keep on looking for all values from I plus 2, and then just compare I greater than I plus 2. Whenever I find that condition to be true, then I return false because that is a global inversion I have encountered, correct?
Yeah.
Okay, so that should be easy, right? So
Yeah, I think it should be.
yeah. Okay. Or else what is the other way of doing it? An optimized version.
Why you are only considering global?
Because every local will be global, right?
No.
Every
When you
local
say I
inversion.
plus 2, when you say I plus 2, you are basically skipping one element in between.
Right,
Yeah,
right.
why? Because for local you need to look immediate, and for global more than one. I mean, immediate definitely will be there, but apart from that, you need to look for one element further, like any j.
Yeah, so whenever we have a local inversion like a of I is greater than a of I plus 1, so that is a local inversion for sure, but that is also a global inversion.
Yeah.
Yeah.
So they are equal, but when I find just a global inversion, which is not a local inversion, so that means my global inversion count is greater than the local inversions count. And therefore I'll be returning false. So the whole crux of this problem comes to like I have to find a real global inversion, which is not a local inversion. So when
But
that case is there, in that case it cannot be local inversion, which is the consecutive ones. So I have to look any number which is other than the consecutive ones. So that is the real global inversion. I'm sorry, Shashank, go ahead.
so I was saying, like a of I, we are comparing with a of I plus 2. There is global inversion, and if here also if you have one local inversion, then both will be equal, right? No, again global will increase. Yeah, got it. Yeah, because there again one additional global will be there.
Yeah, so whenever we have a local inversion, it has to be a global inversion
Global.
also.
Yeah, perfect. Yeah.
So if we just ignore counting the local inversion and we just find the real global inversion, so we skip the consecutive comparisons, and then we find any one which is true, a global inversion, then we have to return value false because the global inversion count will always be greater than the local inversion count.
Yeah, that's right.
So for here, for example, right, 1, 2, 0. So you start with 1 and then you compare 1 with length of a minus 2.
So it is 1, 2, 0, right? So what we do is for local inversions, in this case, we have, so 1 and 2 cannot be local inversions, but 2 and 0 can be, right?
Yeah.
So 2 and 0 are local inversions. But for the global ones, what we'll have, we can say is 1 and 0. So this is one pair, correct?
Yes.
And then if you look for another one, will be also 2 and 0. Okay. So now if you look at the 2 and 0, here it is at the local also and global also. So if we just remove them, so we have only one global inversion, which is the real global inversion, right?
Yeah.
So therefore, we just ignore the counting for the local inversion. We just look for any global inversion, which is not a local inversion. And so that will be our answer. So we'll return false in that case. Yeah. Okay. So the other way we could do is, we can have some sort of something like a different array or so, right? That is what you are trying to do, Shashank, correct?
Yeah. No, yeah, I'm doing the one which you have explained just now.
Okay. How was that? But that was O of n square, right? No, you are doing it in O of n.
Oh, yeah. So mine is like this. I mean, less than because -2 because like if you are at what you say last -2 index, from there only you will come out, right? You don't, otherwise it will go out of the index. And I've initialized a max variable, and I'm checking every time if a of I is greater than max, then I'll update that maximum. And this is for the global I'm checking. If it is less than that, then false, otherwise true. It's
Oh,
like,
so you are trying to find the max value and you are starting from the last value. So you are starting from the right side of that array, and then you
no,
are trying
left
to
side.
find the max value, right?
I'm going from left to right only.
Oh, okay. You are going from left to right,
Yeah.
and then you are trying to find a max value for the current value.
Value, yes. And comparing it with global I+2 2th index. If that is lesser than this.
Oh, okay. Yeah. Yeah, so this is good because this is very optimum. You can actually do it in single pass, right?
Right.
So the way I was explained was a one square solution, but this is the efficient one. So what you are trying to do is that when you are starting from 0 from your left to right, so you are trying to you are actually looking for a global inversion here, right?
Yeah.
So
Every time I'm getting the maximum at each iteration.
yeah.
And checking if the global condition satisfies or not. If it doesn't satisfy, then I return false.
So the global condition should satisfy, right? So here
Yeah,
on line 7, A of I+2 is
take the
less
example.
than mx, right? So that is what
We
the
get,
global inversion. So whenever you find a global inversion, you return false.
yeah.
Right. Yeah, I think that is good. This is the most efficient way of implementing in this case, correct?
Yeah.
Yeah.
And what they are saying in the solution in the hint also, like because if you look at the value 0, if you just focus on the value 0, what they are saying, no, where can the 0 be placed is an ideal permutations.
Yeah, even I was thinking that. So the index actually says which is the ideal position for that value.
What is ideal position here? Ideal permutation?
So the
Perfect.
values go from 0 to n-1.
Okay.
So ideal position of 0 is 0th location, 0th index. Ideal location of value 3 is fourth index. Like if we start from 1.
Okay.
Yeah, so just see which all values are not on their ideal position, and see if they are two indexes apart, like further, 2 indexes further than the ideal position. Then that's the global inversion.
So ideal is like element should be at their correct index, right?
Yeah.
Okay.
So indexing starts at 0. So ideal
Okay.
position of 0 is index 0. Ideal
Yeah.
position of 1 is index 1. Now suppose if we find the element 1 at index 5, it should have been at 1 ideally, right?
Yeah.
But it's at 5. So that's the
So,
global inversion.
okay. The element
So, any index, if a of 0 is greater than, if 0 occurs at any index greater than 2, right?
Yeah.
Or 2.
Yeah. Yes.
So that is a global inversion.
Yeah.
And if it occurs at 0 or 1, so if it occurs at 0, then it is not a global inversion for sure, correct?
Right.
Yeah.
Yeah.
And if it occurs at 1, also it won't be a global inversion. It will be a local
it's
inversion.
local. Yeah.
Okay.
So if we take
with the condition
your
that should be,
idea,
so if 0 occurs at the index 1, then at the index 0 we should have 1.
yeah. So
Yeah, but
something
any
like
number,
if
right? Any number
not-
other than 0, if that index that number is at the index 0, it will be still a local inversion, right?
Can we draw one example?
Because see, 0 is the least number, and if we have that at index 1, so whatever number we have at index 0 will always be greater than 0.
But the
Yeah.
other things would be vectored. Like if we take 3, then say 3, 0, 2, and 1. Right?
Okay, what you're saying? Can you draw it here?
Yes.
Okay.
3,
3,
0,
0,
2.
2, and 1.
Okay.
So this is not a valid answer, right?
So this is your 0, this is 1, this is 2 and 3.
This 3 and 2 will form that global inversion.
So you have two global inversions extra.
Right. So what I'm saying is that, as you said, 0 can be at 2 places, either at index 0 or index 1. So if it is at index 0, then it does not matter. But if it is at index 1, then at the index 0, only 1 can be there, I think.
Why only 1? It can
So
be any number. Right?
if you interchange 1 and 3, then we can say that this is a proper permutation.
So if you have 1, okay, you are saying like if I have 1 year, 0 year, 3, and oh sorry, this is 2 and 3, correct?
Yeah.
Yeah.
So this is local inversion. Okay, so this will be, yeah. Okay, so they are all in the ascending order, correct? Yeah. So this is very important, 1 and 0.
Yeah.
So I didn't get like what is the point?
so like this is just a thought I did not implement, but for example, let's take 3021, the example which you wrote previously.
Okay.
We'll check each value. Let's start with 3. So what should have been the ideal index of 3? It should have been 3, but it's 0.
Yeah.
Yeah.
Okay.
So 0 is not greater than 3 plus 2, right? Greater than equal to.
3 plus 2.
Let's take the simple one in this. So in 3021, let's say we are looking at the like for example, let's say an index of 1 should have been 1, currently is 3. So 3 is greater than equal to 1 plus 2. So this is the global inversion.
Yeah, so you're saying if it is 3021, that is a global inversion, correct?
Yeah. So I was looking for the value 1 in the like we have. So what I'm saying, we should iterate through all the values and look for each value if its ideal position, if its position is greater than equal to ideal position.
Okay. Yeah, because in this case, if you look at 3 and 1, okay, because 2 and 2 are at the right place, correct? So 3 and 1
Yeah.
and 0 and 3.
Yeah.
So because the
Yes.
index and this one are different. Yeah, makes sense there.
Yeah.
Yeah. So for every element, like what would be the ideal position? I think it can either be, at its own like proper ordered position, or one left or one right.
So it has to be two right or more. So what Shashank was
Right.
saying previously, we should look for only global inversions. Like that's the only, like if there are more global inversions, I mean, every local inversion is global inversion. So we can just ignore that thing. So we only are interested if there are any global inversions. If there are any global inversions, which means local inversions are less than global inversions.
Right. I got that. So I'm saying that I'm trying to figure out the ideal position so that we can
It's the
return.
same index.
Yeah, the same index should be the ideal position.
No, not necessarily. It can be like one left and one right also.
So if you have one left and one right, so other will be mismatched, right? So if you are just pushing one ahead, so there will be one integer which has to be at an improper position.
Right.
So then
if
that will
it-
create a global inversion.
If this is 1023.
So if you take it the way, so okay, if it is the normal one is 0, 1, 2, 3, correct? So this is the ideal position. And so if you just shift all of these to the right side, so what will happen? So 3 will have to come here, right? In this case. So 3,
No, let's take
0, 1, 2.
Let's take 0, 1, 2, 3, 4.
Sorry, what you're saying? Okay, let me just erase all this
0,
stuff.
1, 2, 3, and 4. One more.
0, 1, 2, 3,
2, 3, and 4.
4. Okay.
Yeah, and let's not disturb the first two, 0 and 1.
Okay.
And let's put 4, like just jumble 2, 3, and 4s anyway
How do you want?
amongst themselves. Let's do them as
3, 4, 2, something like that.
yeah, 3, no, 3, 2, 4.
3,
Okay.
2, 4.
Yeah. So 0, 1, 3, 2. This is a true case, right?
3, 2, 4. Yeah. Okay. So in that case, so you're just saying 0, 1 will be at the same position. So our indexes will be 0, 1. Okay, these are the indexes. So we have these two at the same index. So this is not at the same index. So this is at the same index. Okay. So
Right.
we have a local inversion here and a global inversion here. And
Why is this? Okay, so
This is a true case, right?
Yeah,
right,
there's no
it's
global
a
inversion
true.
here.
Yeah.
Yeah.
So what I'm saying
So-
is that value 2, it can either be at one index to the right or one index to the left.
Or
If,
it
like,
can be more. I think there are 3 cases, right? For the first case is the value is at its ideal position. That's the first case, which is very basic. The second case is the value is one off from the ideal position, like the absolute difference.
Right.
And the third case is the value can be more than one from its ideal position.
I
Right,
plus
that
2.
will be a false case.
Right? That will be the false case. I think we are only looking for the third condition. If that is true in any case, that means,
Right.
we are returning false. And to do that, we are just looking at every value and then seeing the index of it and then just finding the absolute difference.
Yeah, if you find the absolute difference between the value and the index, if it is greater than 1,
Greater
right?
than 2. Oh yeah, greater than 1. Yes.
Yeah, if it is greater than that 1, we say that is a global inversion.
Right.
Yeah.
Right. Yeah.
Yeah, actually,
that's-
that is what it comes to. But actually, if you see the way the explanation is, he says that you need to look only for the 0. You know, if 0 occurs at index 2 or greater, okay, because a of 0 will be greater than a of 2, then it is a non-local inversion, which is actually global inversion, right? So 0 can occur only at index 0 or 1. Yeah,
is that's a condition?
yeah, that's the condition.
That seems to be a corner case, like a special case.
Yeah.
What if it is not? Like let's say 0 is at index 4. What happens? And then there's definitely a global inversion.
Yeah, it has
Yeah.
to be a global inversion. Yeah. Yeah, because if you just shift this one over here, so either 4 comes here or maybe any number which comes here, that will always be greater than the 0.
Yeah.
Either even 1 comes here, so it will be greater than. Yeah. Yeah, but it will be very tricky if someone actually in an interview keeps on, you know, confusing us all this based on the indexes, right?
Yeah.
So we might come with an optimum solution, but he will keep on asking us more about how we will handle all the edge cases. Yeah, good one actually.
That's a good one.
Yeah.
Yeah, thanks for sharing this.
Yeah, thank you. It was common, right? Yeah. Thanks, Shashank. Yeah, good, Shashank.
Sure. So next is like minimum distance between two BST nodes. So a BST is given and the root is given. We have to return the minimum difference between the values of any two different nodes in the tree. So 2 and 1, this is the difference is 1, right? It occurs between node 1 and node 2 and also between 3 and 2. Okay. Size of BST will be from 2 to 100 and it will BST is always valid and each node's value is an integer and will be different. Okay.
Can you scroll up?
Sure.
Yeah.
Okay.
Okay, so now this is a binary search tree, right?
Yeah.
So if we do, okay, I think there is nothing much for the requirements clarifications, correct? Or is there?
I think almost everything they have mentioned only.
So it might be integers, it might be float values, something like that, but actually it doesn't make sense if it is typed array, right? Okay, a single type array, yeah, it's integer or float, so then it won't be a mixed array that way. Yeah, that is true. So in this case, only.
So what is this? The BST is always valid. Okay, a property of BST like left should be lesser than root and right should be greater than that, right?
Yeah, so BST is BST. So why the validity comes into picture, I don't know, but that is fine. Yeah. So in this case, the very brute force would be just do an in order, get all the into an array, and then run through the array, right?
The difference minimum, whichever.
Yeah, just find what is the minimum difference between all the nodes. But then that will be bigger time complexity as well as space complexity.
In order because it will give you a sorted one, right?
It will be O of 2n, right? Yeah, Arshit.
Why 2n? I think O of n square.
No, O of n for in order, right? That will give you
Okay,
sorted.
it is sorted. It is sorted. Okay.
Yeah.
Yeah, it is sorted, right? Yeah. So you just traverse the array again in a single pass.
Yeah, we can maintain 2 pointers.
Yeah,
Why 2 pointer? We just comparing consecutive, right? Because it's always increasing.
Right, right. Yeah.
Makes sense. Yeah, that will also work. Yeah, but only space will be more. So then what do we do with this without?
Every time you go to the
we
next
can basically
level, you pass your previous value to that and compare it at the same time. Like when you go to 2, pass 4 there and compare. And when you go to 1, just pass the 2 to them and you get a comparison, right? At every call, you pass the previous value of it and compare them.
Yeah, but how do we do that? See, Because when you are even in an in order, you don't know where you are coming from. You don't know the parent or the root, correct? If you are in a left or right.
So we can
No,
keep going.
when we are doing in order, right? Whenever we are coming from the last pass, right? We are passing the last value to the next. Like we are just maintaining a previous pointer.
Yeah.
Which will always point to the last processed value.
Okay.
And then we are standing at the current node, and all we do is compare it with the last value. If it is, if the value is decreasing from the last value, I mean, we can just take a difference, right, from the last value and see if it's lesser than minimum. And so we are tracking a minimum also.
Okay.
So every consecutive nodes, you are taking the difference and passing this difference to the next level and checking which is minimum.
Not the difference. We are passing the last value itself, but we are maintaining. So there's a global. I don't have an implementation. I should have an implementation, but all we are doing is we are tracking a global minimum.
Okay, that is okay, fine.
And then at every pass, we are sending the previous node that we processed. So to start with, the previous node is null, and then as we move on forward, in the in order traversal, we just pass the previous node, that value of the previous node that we just processed. And at the current node, we'll just do a difference and see if it is lesser than minimum. If it is, then we track that.
Okay, so when you are saying like if you do a recursive way, right?
Yeah.
And in the recursion, you actually pass something like a pointer and the current root. Okay. And then when you come here, you know that this root, whatever your current root is, it has a parent. So you just subtract that number from that. But then when you go to the in order for the left and right, you just, is that not a pre-order then?
I didn't get that. So let's take this example 4, 2, 1, 3, 6, right? We're starting from 4, with previous is null. Then when you go in order, you're trying to process the left first. Then you go to 2, and the previous is still null. Then you go to 1, and the previous is still null. Then after 1 there's nothing. So you set previous to 1. And then see, there's no, since the previous was null, the difference, let's say the difference was maximum into maximum. Okay. So now the previous becomes 1. And then since you're in recursion, you fall back to 2. And then you're seeing, your last difference was infinity, but now 2 to 1 is just 1. So the minimum of that is 1. And then you move to the right of 2, setting the previous to 2. So basically, in your method signature, you're passing a pointer to current node, but then you're also passing an int value of the previous node.
Okay, so you are saying like if I have something like I say void, and then so something like fn, so you are first passing a tree node, right? Okay.
Yeah,
so
first point, a tree node and
an int value.
And an int value.
Okay, maybe int v. So in this case, so you actually check for if equals root, correct? Then it will be returned, right? Something like that. Okay, you return it from here, but then you are actually going to look for, you said you have a minimum global variable, something like that. So this min v equals something like a min value of min v, and then you are going to look for rt dash val minus v, right? And then you are going to take an absolute value of that one.
Yes.
And then you are actually going for fn rt left and right, correct?
Yes, passing this as a, yeah.
But then this is going to be a pre-order, right?
Yeah, so what is the problem in that?
So if you are doing a pre-order, okay, so you are at the root, right?
Yeah.
Okay, so when you are at a root and then when you are passing these values, when you are actually setting this value v, right? So you'll be setting the value v over here, right?
No, let's set it after the left call.
Okay. Then you are saying that you shift the whole stuff after the left. Okay, then that then it will be in order. Yeah, but will the pre-order work? That is, I was just thinking about.
No, I don't think so.
Mhm.
Why? I mean, there is a global minimum, and we are taking difference of root with left and right. So why it shouldn't work?
Because I think, for in order, we go from year to year, okay, to year, and then we do this processing, correct? But for pre-order, from year only, we are doing a pre-processing.
I think the whole intuition is when I'm standing at a current node, I want to know what was the minimum from my left and what was the minimum, from my right.
And take the global minimum both.
Yes.
Like
Yes.
Yeah, but yeah, if you do it the pre-order way, it might not work for some corner cases. Yeah, I agree what Harshit is saying. Okay, no problem.
I think we can take this also as global, this int v. This is for the previous one, right?
Mm-hmm.
So I think we can take that as previous, and whenever the root becomes null, we can initialize that.
Mm-hmm.
So when are we initializing this int v?
Int v, actually, that's a good question. So initially it will be int max, something like that, correct?
Right.
Because
You can have a caller function that passes it as int max.
Right. So something actually a wrapper to this function, correct?
Okay.
That makes sense. Yeah. Okay.
your mind was like the one you were mentioning, doing in order and then putting into array and calculating the consecutive absolute difference. So whichever is minimum out of them, I'll return.
Oh, okay. Yeah. Yeah, but the only downside of this is you have to use an array, right? Yeah, but the time complexity wise is still okay. It's not a problem, right? Yeah. But I would say either use the way what Biju was saying, okay, implement, or we could actually do a iterative way also, correct?
Using stack.
Yeah, using a stack. But yeah, again, stack. Anyway, if you're using recursion, you are still using a call stack, correct?
Yeah, but yeah, on the top of it, one more array we are using.
Yeah, in this case, you're using array, but the way Biju was saying, just use two global variables. One is that minimum v and the int v or something like that. And then do an in order, and then keep on changing that min v as well as int v. Yeah.
So has anyone done with that?
That should be a standard one. Yeah, I think people don't want to do the easy ones nowadays. Okay.
They're using post order also.
Really? Because I thought it is always better to do in order.
This one is post order, right?
Yeah, I see that. But then you are doing two comparisons, right? See, one for the left and one for the right.
Yeah,
And
you're returning multiple ones.
Yeah.
This is what Biju was saying or what?
No. He was saying to do it in the in order, right? We could actually quickly implement that here also, not a big deal, right?
So he is taking from left side minimum, left side maximum.
Yeah.
And again, right side minimum, right side maximum.
Yeah.
So this is what Biju was also saying, looks like.
No, we don't have to take any minimum.
Somewhat.
Yeah,
Okay,
this would stay, but we just have to keep track of one previous variable, and like on the fly we'll calculate the minimum, like he's doing, but we don't have to do it twice.
Okay.
Yeah, I think we can quickly implement it.
You want to try, Arshit?
Yeah, I can try.
Yeah, go ahead. I think you are there on that.
Yeah, same problem.
Okay.
So
Okay.
that was one global one.
Oh, okay. Yeah, something different. Okay.
Okay, let's go with recursive one. Okay.
Yeah.
Okay. So if my root is null, okay, I have to take that void function, right?
Yeah, you can initial answer to 0, right? Yeah.
Mm,
Okay, yeah. Yeah, that's fine because it's still
you can
going to
have
be.
negative value. Maybe.
Yeah.
Okay.
Yeah. Yeah.
So now what we do is ans equals to. Okay, answer is the difference, right?
Yeah, it's
Yeah.
different. Yeah, you are right. It should be in max.
No, why it's into max? Difference can be okay.
I
It can be
minus
negative also.
Answer will be the minimum value, right? So I think it should be in max.
I minus your positive.
Okay,
Big,
let's
yeah.
we'll change that.
Okay.
Yeah, so answer is minimum of answer comma root of val minus of this brev,
Yeah.
right?
Then do an absolute there.
I don't think we need that because in order traversal would always be a sorted traversal, right?
Okay. Okay.
So
Makes sense.
I've already traversed the left part. So
Yeah, makes
my
sense.
current root would always be greater.
Yeah.
Maybe we can check that later.
Yeah. But then you have to change the previous
I have to
also.
change the previous also, right? So previous would be this root of val, right?
Right. Yeah.
Root dot left. Okay, yeah.
Yeah, minimum and this is this. So let's do a small dry run.
Yeah.
So when I come to 1, I would be here like after the left call. Now minimum of 0 comma this.
It will be
Would
still 0.
yeah, it would be still 0.
Yeah.
Okay, that is okay. Now previous is this 1.
Mm-hmm.
Now I go back. I go to the right.
Mm-hmm.
Again, that would be a null call. So I go to 2.
Mm-hmm.
Now at my 2, my answer is 0, and my this I want the minimum, right? So this should be max minimum.
Yes. So your answer, if you set it to 0, you'll always get 0. So you'll have to set to into max or something. Yeah, I think then it works.
Yeah. Return this.
Okay. So what you need to do, your minimum actually, so you should actually, whenever your answer is not into max, right? Because first time you'll have to set your pre value to something, right?
Okay, right.
So if your answer is not okay, if your priv is not into max, then only actually do your minimum. Because you cannot set, you cannot calculate your answer till you have a valid preval.
Right.
Yeah, that's only condition. Oh, I'm sorry. Yeah. Oh, yeah. Priv int max make something. Then- Okay. Yeah. So we have only one test case, but yeah, actually adding any binary BST, it'll be complex, you know. You can just give a try by submit, and then whatever problems are will be covered.
Works.
Yeah, it good.
Yeah,
Yeah.
23.55.
Yeah.
Maybe because I'm using recursion. That's it.
Yeah, so I think even the way if you use an array or this, you won't have any much over time complexity change differences, right? They will be almost similar at least. Yeah, yeah, but good at least. So if you do in order this way, it will work, and then you set two globals. Yeah, but it's tricky, you know. Even now we have a compiler, so we can quickly find out what the issues are, correct?
Yeah.
Yeah. So I don't know about the poster what Shashank was showing very just
Yeah, I
now.
can.
Yeah, but the in order, like whenever I come between those two calls of these recursion, so I know I'm very safe that I'm at the very end of the left one, right? So that from there I can start doing whatever I want. So that will be like the way you are actually putting in an array, you know, and starting from the leftmost in that array, which will be the minimum value. So my pre will always be the first minimum, whatever I have. And then I can go on comparing with I can go on line 23 for the next one, right? So for the next index. So that I'm very sure if it's an in order, I have to just write whatever I want to write between those two recursion calls.
So post order is like I'm taking difference of left leaf with the root and right with the root. Okay, then get the difference of left and right. Right.
Yeah, when you are in the post order, actually you have the information of your leaf because you have traversed the leaf and the root also.
Yeah. And whichever is the difference is minimum, I'm bubbling it up to the root.
Right. So then you'll have to handle, yeah, it might be possible, but it is slightly tricky to, you know, grasp that. In order seems to be very easy because we are at the end always,
Yeah.
especially for BST.
Yeah, that gives an advantage.
Yeah.
Yeah. But in that case, left and right, I mean, highest and lowest value both we have to maintain in post order.
Right. I think in pre-order also you'll have to do that because if we analyze this through your array approach, so here
Okay.
we are like if you do it through your array also, then also you have to keep track of just one variable behind. But if you form an array using pre-order or post-order, then you have to take, I mean, you have to keep track of the left minimum and the right minimum, like
Right. Yeah.
whatever is to the left.
Yeah.
And whichever is
Yeah.
Yeah. You cannot just compare the consecutive ones.
exactly.
So that is what I always feel. Whenever there is a binary tree problem, you have to be very careful. It looks very easy.
But it's
Yeah.
deceptive. Yeah.
Yeah. Even if you have a longer implementation in your mind,